So just to begin, I'm just going to start with a little background on, who we are, both the panelists and us as a company. So this webinar is presented by Ceres Greenhouse Solutions, and all of our panelists hosts are from Ceres Greenhouse Solutions. And Ceres Greenhouse Solutions is a company devoted to designing and engineering energy efficient growing systems. Ceres recognizes that beyond providing a well-designed facility, integrating appropriate technology and focused data, as well as smart partnerships, it is essential to create greenhouse facilities that both consider the environment and make financial sense. Our panelists today are Marc Plinke and Josh Holleb. Marc is the founder and chief innovation officer for Ceres. Marc is an inventor, innovator who started his career as a chemical and process engineer working for GAHT Technologies. When he landed in Boulder, Colorado, he retrofitted his family's 1950s ranch house into a beyond net zero energy home. That experience led him into a second career in greenhouse building design. He spent the past decade applying his engineering mindset and expertise to building better and more energy efficient greenhouses. After helping build a state-of-the-art commercial greenhouse funded by the Colorado Department of Agriculture, Marc started Ceres with the intention of enabling people to grow their own food sustainably and year-round. Marc's passion is his family and his belief in leaving the world a better place for his children. Josh Holleb is a systems integration specialist at Ceres. Since starting at Ceres 13 years ago, Josh has created the cannabis division, helped design the Ceres Sun Chamber, and developed the Vesta Kit House, bringing more than a decade of experience in design, construction, and cultivation. Josh approaches his job with an interdisciplinary understanding of systems, architectural design, and problem solving. His goal is to create a whole systems approach to both greenhouse design and environmental controls, resulting in the most efficient systems and highest quality product. Also, as a panelist, we have Haley Liddell. Haley will be accompanying me as a host, actually, and she is a content marketing manager. And she does everything social media content, and will just be answering people's questions, be interrupting with relevant questions, and will be closing out our webinar today. So just to give you all an idea of what we will address today, a little outline. We're going to start with questions about climate control, HVAC, environmental controls in general. Then we'll move to greenhouse design questions, followed by greenhouse sizing. Then we'll move on to the value of a greenhouse, energy production, and we'll finish with grow systems. We're going to try and end a few minutes early so that we can answer some follow-up questions if anyone has any. We just want to issue a small disclaimer. We might not get to all the questions. There were a lot of questions that came in, and we really want to focus an appropriate amount of time per question so that the questions that you provided are answered. So in order to provide that value, we might not get to all of the questions. If we haven't answered your question by the end, feel free to send us an email, call us, or if there's enough interest, we will do a round two. And with that, we will start. Just before we get into anything, I just have to issue a disclaimer to protect us as a host, webinar host, and as a company, that this webinar is for informational purposes only, and no answer provided here should be considered legal advice. We're not responsible for any losses, damages, or liabilities that may arise from the use of this webinar. This webinar is not intended to replace professional advice, and the views expressed in this webinar may not be those of the host or the management of Ceres Greenhouse Solutions, LLC, per se. They are the views of the panelists who work for Ceres. So with that, I am going to move into our climate control questions. And we will start with a question about the GAHT, and we will have Marc answer this question. And it's specifically, how well does a GAHT system work in cold climates?
Thank you, Miriam. I thought I'll go first to our website maybe and talk about what the GAHT is, and then we'll talk about this. So some people may not be aware of it. It's GAHT, the expression came from a geeky German engineer, not very descriptive ground-to-air heat transfer system. It basically takes, in the daytime, especially in colder climates, it takes the warm air from the top of the greenhouse, puts it into the ground. In the ground, it will be cooled down, and the air comes out cooler than it went in. So that's the daytime operation. Now, in the nighttime, when the greenhouse needs to run, when it's outside, it's freezing or below even, you can heat your greenhouse to 50 degrees Fahrenheit or 10 degrees Celsius. Just by doing the same thing, you're basically taking cold air that comes in at the top, and then you're expelling warm air at the bottom. So this is basically under the ground. You're using the earth, and ideally the earth that you have in a local soil, as a climate battery, right? You want to keep as much of the energy inside the soil and use it when it requires it. So the question, does it work well in cold climate? Absolutely. That's what it's really designed for. It's a great heating system. When it works really well, then you're probably in a place where you have quite a bit of sunshine in the daytime, so that you actually have enough energy coming into the greenhouse that you can then store in the soil. That's kind of the general idea of this. If you're living in a cold climate that is always cloudy, then the GAHT system is not all that helpful, because you never really get to the energy storing system. It is also the case that the Earth has a certain temperature, and that Earth temperature will help keep the greenhouse also in a warm enough state because of the GAHT system. So the heat from the soil actually goes into the GAHT system as well, and then that helps you to heat your greenhouse. And so I think that's in general how it works. I want to, even though that wasn't asked, the GAHT system is helpful to keep the greenhouse cooler than it would otherwise be. But a GAHT system alone in the summer in a very hot climate will not bring the temperatures inside the greenhouse to a temperature below the outside temperature. That is just so much energy the sun is providing that the GAHT system alone will not really do that kind of a cooling. But I think Josh will talk about cooling later, so I'm going to leave it like that.
Anecdotally, I will say, Marc, we often say in the winter on sunny days, so winter temps outside, let's say 10 to 30 degrees Fahrenheit or something. Sunny day, greenhouse will need cooling. The GAHT can provide that cooling. It's a great winter cooler, as Marc said. And that allows it to heat better at night if it's putting that energy in the ground. I was just at a farm in Wisconsin just a few weeks ago. And she told me that she produces lettuce year round in her greenhouse, minimal sunlight, no heat, just the GAHT system all winter, which is interesting for us to hear. It's not high production. Normally you'd want it at 65 or something, but she said her GAHT is keeping her greenhouse around 45, 50 degrees, and she only has to turn the heater on during very cold multi-day stints, like negatives. And she is growing lettuce year round. So that was nice to hear. I hadn't told you that, Marc. So now
no, it's fine. And I wanted to maybe show a picture that the beautiful thing about the GAHT system is the ability to somehow it doesn't move away. That's an interesting thing. It did earlier. Oh yeah, here. So here's the GAHT system in operation in a greenhouse in Ontario. The GAHT system in a commercial system is quite powerful. So there's a lot of air that needs to be moved. Otherwise, the system just won't work. And so the power of the system is directly proportional to the amount of air that you can move. I also wanted to show in a smaller greenhouse, this is how it was installed. That's the upper layer of 2 layers. The lower layers, usually somewhere in the range of 4 feet or 1.20 meters. And then the upper layer just roughly at the 2 feet level, so about 60 centimeters or so. That's the upper layer. It is, in this case, the GAHT system is installed on sand. We don't really like that a lot. We'd rather see people install the system in natural soil. That's a benefit, is generally looked at as an advantage. Also, when you make the system big air, then, you know, this is a bigger system for a greenhouse here in Boulder. The inlet is here on the right side, and then the air goes through here. It goes all the way the distance of the greenhouse, and this is about 40 feet. On the other side is the exhaust, and then this air is going to be mixed. Again, this is a 2 or 3 layer system. It's not just 1 layer that you're seeing here. That gives you an idea. You can make these systems as big as you want. They can be an acre size if you want or more. There's just design considerations of how to get there.
Thanks, Mark. Moving on to the next question, just about heating. So similar. Which alternative heating methods are the most economical to implement?
Yeah, so the GAHT system we have talked about already, and it's, you know, having been or designed a house that is actually energy efficient, the first thing that everybody told me, and I think I followed very well, is insulate, insulate, insulate. So the more insulation you get into your greenhouse, the better any system will be. And as Josh just said, there are people that literally run the greenhouse in Wisconsin, also here in Colorado, where the temperatures can get down to -20, -30 degrees. And they don't have a heater at all. That is possible when your greenhouse is really well insulated and very sealed, meaning you don't have a lot of air exchange from the inside to the outside. And in those cases, you know, the GAHT system is a great way to heat. Other ways to heat, and you know, everybody knows about heaters that we can get from that you can buy online. Here's the standard in the US, at least, for smaller greenhouses. They're called hot dogs. You know, $1,000. You can buy these from Modine as the company, and they have all kinds of heaters. They can be on natural gas, they can be propane, and of course they're electrical heaters. So in areas where you really want to not have any contribution to our climate issues and not expend any more CO2, you can use electrical coming from a PV system to achieve that. Other things that you can do, and I would think most people know about this. So there are other things that you can do that I thought I wanted to point out. One that I'm really excited about is, this is a greenhouse also here in Boulder, 3,000 square feet, 300 square meters. It has a PV system that is big enough to really provide electricity to the whole farm. That's awesome. But on this side here, you can actually make hot water. These are hot water panels. And you can see how they look, and they go actually, and this is a system I really like. They make that heat, put it into a small heater. This is rather a very, very simple system. And from the small heater, it is basically put into the ground. There's basically tubing in the ground, and that's where you heat your ground. It's a very efficient way, also not a very expensive way to do this. Other things you can do that are a little further out, compost piles. One client that has set compost piles. That's the inside of the compost pile. When he was done, the compost pile looks like this. The compost is decomposing, making compost for your farm, and can create temperatures that are somewhere in the 160 degrees Fahrenheit range. They can be quite warm. And then you use that water that comes from this compost pile. You can put this into the soil and heat your greenhouse all year long. Other things that you can do, which we haven't done all that much because we haven't really found very good suppliers lately, is phase change materials. So these are materials, in the old days, we used water drums or 1 gallon water jugs that we put on the north wall of the greenhouse and just let the sun heat that up. This is a lot better to do that. It just changes from solid to liquid, and that change of the state of this material can significantly alter your the energy that is needed. When you do that, what you can get, here you can see a greenhouse where we took a thermal camera to it. In this case, this wall is about 76 degrees, which is the transition point from this material, and it stays, the whole wall stays at that temperature. Whether or not it's cold outside or warm outside, it will stay always on the same temperature. Quite an interesting material. Again, we have been lately not very happy with suppliers. I know in Europe, they may be a little better than here, but it's a technology that's certainly coming and is going to continue to come. And then I wanted to talk about one more thing that comes up more now, that is energy curtains that will allow the energy from the inside of the greenhouse not to get out. So you basically create an energy curtain that is completely clear. Those exist right now. We make those out of ETFE, and they allow the heat that's inside the greenhouse from not exiting the greenhouse. They have a special coating on them. So this is kind of like a new thing. We're in the last stages of experiments of the first commercial samples, and then this will be something that will be coming out pretty soon.
And I can, I'll share an image of that shortly. The other thing we think about when we're talking about heating is what your needs are, which is always good to mention. A commercial year-round tomato producer is going to need something very different than your backyard gardener who's just trying to maintain some lettuce and some other things through the winter. So where a GAHT system might be totally sufficient, for one grower, it might not be sufficient for someone else. And so location, amount of sunshine, and low temperature set points throughout the winter all matter significantly when we decide how we're going to heat the greenhouse, and to choose both what is most efficient, but also what is going to be most effective for the grower's needs.
I do think that it's important to say that for most people, worry about temperature. Don't you think, Josh? Most people think the temperature is the biggest issue for the greenhouse in the winter, which may not quite be correct, because often actually humidity is a bigger issue, especially depending on how you grow. If you're growing in soil, you get quite a lot of evaporation on a warm day, sun is shining, and then at nighttime, everything is going to be drenched when it gets cool. And then your plants are really not happy. So I want to encourage people, especially in the more northern regions of the world, that includes, anybody in the US, north of the line, I'm going to say Colorado to New York or so, they really need to think about the humidity in the greenhouse in the winter. And that, of course, goes to all the European countries, Germany and North, Denmark, Sweden, Finland, etc. They all have the same issue, that humidity on the plants, water on the plants is never a good thing for any extended period of time. So one way to get around all of this is by actually having a quite insulated greenhouse and having a dehumidifier installed. And that dehumidifier actually creates, if it's a good greenhouse, enough heat by itself to heat the greenhouse also. So that may be another way of how to control the climate well. And then for commercial, really big commercial facilities, but even in the backyard, there are now heat pumps that we use, ground coupled or otherwise. Heat pumps are in the rage. We have been doing this for years now, and installed quite commercial systems that are very, very energy efficient because we were able to couple the heat pump operation with the ground. And so those are more expensive and elaborate systems, but they can also be run purely on electricity. And in that case can be really climate neutral, which is really for a very valuable goal to have. And so I don't want to put that out. That, the hobby farmer will probably less go that route. But if a greenhouse, I think the smallest one we have put in place was probably in Austin, Texas. That's what, like a 200 square foot building?
Yep.
Right? 200 square foot building, 20 square meters with a heat pump. An excellent restaurant, wanted to grow salad greens amongst other things in the middle of the summer, in the Texas summer, which is really hot and humid. That is possible. And so we don't want to leave those high-tech solutions out when I talked about very, very low-tech solutions first.
Thank you, Marc. I just want to interject and let everyone know that the chat is working, and Haley has been posting just some follow-up links if anyone wants to learn more. There's a video and a page on our website where you could learn more about the topics that we are discussing here. So moving on to questions about cooling now. I'm going to ask Josh. There's someone who is looking for cooling methods for hot climates, specifically hot and humid, besides air conditioning. If you could speak to that, please.
Yeah, so I think like heating, it depends on location and desired or needed set points in the greenhouse. And so we can always go from low tech to high tech. Air conditioning is a word that we try and shy away from because it's kind of, there's been a lot of people trying to use air conditioners to cool greenhouses, and it was kind of an inappropriate technology to cool a greenhouse. Whereas now, maybe we're still shying away from this, but we can use these heat pumps like Marc was talking about that are electric only. We have our own heat pumps that are designed for greenhouse specifics that can do heat, cool, and dehumidification. And so those are active HVAC systems, active cooling systems. But if you have a needed set point, we can always hit that set point, but it requires energy input, operating expenses. As we scale back into more commonly used or more passive cooling techniques, we just have to keep in mind that it's very climate focused on whether we can make the greenhouse cooler than it is outside. Because when we're venting, outside ambient conditions are kind of the baseline of the whole situation. Ceres is based in Colorado. We are a very dry climate. The desert regions, dry regions are lucky because if we add water and evaporate water into the greenhouses, we can drop temperatures, and often significantly, like 20 to 30 degrees Fahrenheit sometimes. And so in dry regions that are hot, we can make the greenhouses cooler. We can also incorporate shade systems, both exterior fixed shade systems, which doesn't let any heat in. We have a shade paint that we've used in the past. You actually paint it on in May or June, whenever greenhouse gets too hot, and then you actually remove it with a special paint remover in the falls, September. And then now we're getting into these new glazings that are movable curtains, but they're clear but they're potentially infrared blockers, or even our greenhouse glazing itself that can block infrared potentially. This is new technology. We're just learning and maybe starting to incorporate very gently into some projects, and Marc can speak to that. But the goal, the idea there is we're still letting in all the sunlight that the plants want and need, but we're eliminating a lot of the farther red spectrum that is really heating the greenhouse. And it is absorbing it, Marc.
Oh, yes. Well,
Uh,
it's
and so the light's coming in, but the glazing is kind of eating up the heat a little bit, which is a really cool concept. And especially for humid, like the Southeast, hot, humid places, this could be a big deal, where we can kind of eliminate some of the heat that venting in those greenhouses can't deal with, and that evaporative cooling can't deal with.
and I think the most, I mean, I'm so excited about these materials. There's both absorptive materials and reflecting materials. Absorptive materials basically just means there is something added to the glazing material that just absorbs the infrared portion of the light, which makes that glazing material slightly hotter, but the heat is not coming through. That's one option, and you can get that from anything super simple and relatively cheap for hoop houses as well. And it is such a great way to, without having to use any mechanical equipment, you can just put a new glazing on. Prices are very reasonable to then run your hoop house or multiple hoop houses up to acres and hectares of them with significantly lower temperatures inside, somewhere in the range of 5 to 10 degrees Fahrenheit, or 2 to 3 Celsius centigrade to 5, 7 degrees centigrade less inside. That without you having to do anything, no energy used. That's one. That material is specifically good for hot parts of the world. We're talking about the Southeast, Arizona, Southern California, etc. Of course, in the Arabian room and Southeast Asia, all of those places where it never really gets cold, that's ideal. There are materials that do the reflection of the infrared, which for many of the people that we also deal with is big, because the reflection means the sun is shining, the heat wants to come in, but it's reflecting back out, and that's great. And if even better, if you can now make that in a shade cloth that you open and close, so that when you want it to cool, it will do the cooling. Then there is a part of the day where you just don't want anything to happen because you're going from a hot part to a cool part. So who cares, right? You want it to be normally open. And at nighttime, you want to close it again. And there you keep the heat that are in the plants. They're radiating off heat as well. That heat will be reflected back to the plants, which makes the plants just like having a really warm, fuzzy blanket around them. And it's a great technology. Again, we're quite almost there. Will be commercial in a few months. The first people already lining up. It's like, I want this. This is the coolest thing ever. And it is. So we're testing, longevity, etc. But again, those prices are very reasonable compared to any mechanical equipment that needs to be installed.
And the question here was on cooling, but what Marc's saying, it's cool to expand on this. And again, I'm just so everyone understands, I'm like a builder guy who used to grow stuff. Marc is a chemical engineer. So we have a lot of things we can talk about. And then there's a clear divide of when Marc needs to take over and talk about dots in films. The cool thing about this movable shade, so if we're talking about an IR blocker, whether it's absorbing or reflecting, if you put it on the exterior glazing of your greenhouse, it's always there, right? So in the summer, you might be quite good at cooling when this technology comes out. But in the winter, you want some of the warmth. If the sun's out, but you have an IR blocker, you're going to have a cold greenhouse and you're going to have to heat potentially. we really want that warming in the winter. And so putting this on a movable curtain and allowing us to use just full sun when we want, or blocked sun when we want, is very cool and exciting for us, because it helps summer and winter, both keeping heat out in the summer, allowing heat in the winter, holding heat in winter at night. So, you know, it's all the things. And it kind of blends the lines between heating and cooling and everything else. But it's very fun. It's cool to talk about.
Thank you.
Did I get them all? Evaporative cooling, exhaust fans, roof venting, mechanical cooling. Okay, those are
And just to remind everyone, if something isn't touched on, feel free to ask a follow-up question in the Q&A, or send us an email, or give us a call. So Josh, another question about cooling, how to incorporate a greenhouse or solarium into a house design to help with heating in winter, but not have overheating in summer.
Sure. So we actually have designed a house.
Uh-oh.
Josh, I believe you muted yourself or got muted accidentally.
Is that better? Sorry
Yep.
about that. We have developed a house, actually, because one of the goals, after a decade of doing this, we had a little bit of time. And so we finally were able to design this house with an attached greenhouse, which is something that we always want to do. And we've done with a few projects in the past. Oftentimes the issues are humidity in the greenhouse affecting the house portion, an overheating greenhouse potentially affecting the house. And so what we've done, and we've done this with clients in the past, mostly with good success. But the big thing is creating a separation, really, between the greenhouse and the house. So we did a project in Netherland, Colorado, where it was full exterior siding on the house wall. So it had a vapor barrier, hardy backer, which is like a concrete cement board siding, and then we attached the greenhouse. So they were truly two separate structures. So if the greenhouse was really hot or humid, it wasn't going to affect the house. That's a big deal. In the house we designed, we have a full right here. This is a full insulated metal wall, and it runs the entire top to bottom length of the south wall, and then the greenhouse comes out. So again, we have a fully insulated wall that separates the house and the greenhouse. We also have sliding, this isn't the best picture I'll show you, but we have sliding glass doors and windows that we can connect the environments between the two if we want to, but you also always have the ability to totally disconnect the greenhouse from the house, which we think is very important, just in case, because things can go awry with greenhouses. The other interesting thing that we've done, and I can show here, is we've created specific overhangs, both here, this is the south face of the house, and also solid roof here on the greenhouse. And the reason we did that is to prevent direct sunlight in the middle of summer to come in through any of the windows. This is the south wall of the house without a greenhouse here. So the solid roof over the greenhouse shades these windows in the summer, and the overhang of the roof up here shades these windows in the summer. And you can see it. We're in the greenhouse here, and you can see this shade line. The insulated roof creates a line, and so the whole south wall of the house is in the shade. So while the greenhouse is in full sun, the house has no direct sunlight, so it's not taking on any heat. This is in the middle of the summer. In the winter, it's actually designed to take heat, so you want it to have sunlight in the winter. We've also designed the windows up here to open and close as needed to let heat from the greenhouse into the house, which is a way to connect the two and use the greenhouse as a heating device, ideally. Miriam, what were the other, did that cover it, or were there more questions to that?
No, I think that covered it. Not have overheating in summer, but How to treat in winter, helping in winter, but not overheating.
It's really important to know that a greenhouse almost always is going to be hot in the summer. It's just part of the game. And so we need a plan for that. So in this design, and in any, if anyone's attaching any greenhouse to a house, we do 10 feet of solid roof on this structure. This is maybe where you're doing your planting, transplanting, things like that. You have a workbench or something. You don't want to be in direct sunlight doing that stuff. There's no need for that. In this house, this is kind of a mud room, so you could take off your shoes or your jacket or something and walk into the house. But greenhouses are hot and greenhouses can be humid, and it's important to manage those things like you would any other greenhouse, whether it's attached to a house or not attached to a house.
Maybe Josh, I can,
yeah.
sorry, add something. I think the two other things, we have done quite a few attached greenhouses. Things to think about are, you want the foundation of whatever that extra structure is if you're doing it retroactively. You want to make sure that that foundation is really solidly connected to the foundation of the house, because you do not want your new greenhouse foundation for whatever to settle and then your greenhouse to pull down on your house or pulling down your house. That you want to be very careful with. And then the other thing that you really need to consider with this kind of a design in general, which we all love, is to make sure that your existing house can tolerate a humid climate that the greenhouse will provide in the winter, so that you don't get mold and fungus growing inside your wall. When there are shingles or siding and water can get into that and stay there, you really need to watch that, so that you either make sure your greenhouse doesn't ever get that humid, which means it definitely needs a dehumidifier, or alternatively, you seal that attached greenhouse to the house so that there's no chance of water vapor to come into the house that way, unless you want it there, which then would say you would have a fan.
And that I think also applies to how you frame the greenhouse. We've used wood framing for attached greenhouses in the past. We've seen other examples where it got too wet in the greenhouse, the wood starts to maybe rot or something, there's maybe mold. When we do it, we do a steel frame to avoid that at all costs. It can work, but these are all things you have to think about, humidity and high heat being the main drivers. There's also a time that you might want to freeze out a greenhouse. If you have a crazy aphid problem because you just aren't keeping up on your garden, you might want to just shut down the greenhouse and open the windows in the winter and let it freeze out for a month. And you want to make sure that your house isn't going to freeze out at the same time. And so having them be separate and insulated, insulation between them is important for all kinds of reasons.
Great. Let's move on to the next question for Josh as well. Is it possible to have a greenhouse that people can garden in year round in Canada or other cold climates?
Yeah, I mean, that one's a little bit of a soft lob for us because every greenhouse that we design is capable of doing that. And when we take new inquiries through the sales pipeline, the answer is mostly a Ceres greenhouse with a GAHT system should never freeze. It's kind of that simple. And then anything else we do from there is icing on the cake or gets you to your desired set points. But, we insulate the north wall, the north roof, the east wall, and the west wall, either entirely or somewhat. And we use usually multi-layer glazings, or if we're doing a single layer glazing, we're adding a shade curtain, which is also a heat retention curtain, energy curtain. And so, yes, we are growing year round all the time. I mean, commercial lettuce production in Ottawa, Canada. We're working all across the northern states. We have a bunch of things going on in Minnesota right now, and we have clients
and Alaska, right?
We have clients in Alaska, and it's the structure. Our structure is designed for that purpose. Yeah. So that's an easy one. Insulation, orientation, appropriate glazings. That's just what we do as a baseline.
Thank you. Okay, well, we'll give one to Mark now. Is there a way to separate areas by humidity? We have collections of both desert and tropical plants. We also have height restrictions due to zoning. So we'd also like to have at least part of the greenhouse have a sunken floor to accommodate taller tropical plants. How would one configure a GAHT system in that scenario? So kind of a few questions all thrown into one, but we think that this compilation of questions can really touch on a lot of people's questions, concerns, thoughts related to our greenhouses. So Mark, take it.
Being an engineer, I always like pictures more than words. So and drawing. So here's a greenhouse. This is an R&D greenhouse that is built in Minnesota. And the whole idea of this greenhouse was that the client wanted 6 different zones that each can be operated completely separate from each other. And so what this entails a few things in the design phase. Our greenhouses generally are oriented east to west. That's so that we can optimize the amount of sunshine that comes in. If we do that in a normal greenhouse, we like to take the air inlet on the east side and then on the west side, and then exhaust towards the east, which is kind of the predominant way how the wind is blowing in most of the places in the US. In other places in the world, that cannot be, of course, be changed. In these kind of greenhouses that are separated, and in this case, the separation, you can see there's a solid wall on the bottom so that wheelbarrows and tables cannot just bump into the wall without damaging it. And above that is an ETFE foil, a material that we love for lots and lots of reasons, that is as clear as you basically can't see that it's there. And so if you want to have this chamber up front to be different than the other one, there's no problem. You have a separation, and the light in both of those chambers, we measured those, is basically equal. So the easiest way is to put a dividing wall in here and make it out of ETFE instead of polycarbonate or other things, which basically means you have exactly the same growing conditions in every single one of those greenhouses. In order for you to get a GAHT system and venting done, here we have inlets on the low side of the greenhouse. We're using
the south wall.
The south wall inlet, using the chimney effect. And then on, why does it not move on? And then we have, so here you can see it from the outside. You have for each chamber, in this case, there's a shade closed. So you have 3 inlets, and you have 1 big outlet on the roof, and fans on the north wall. So the venting is not the traditional venting from east to west, it's from south to north, which means that every single chamber can individually be controlled. And that's really an ideal setup for research greenhouses or your private house, right? Because every single chamber has exactly the same conditions. If you want that from an R&D perspective, or if you want tropicals in one and temperate climate in the other, you can have any climate between the different sections. And when looking from one to the other, you get actually the experience to be in the whole greenhouse, and you don't even know that there are dividing walls because you basically can't see them.
Mark, I wanted to chime in because it's important. In this scenario, it's not something where we can retrofit. So if we design a greenhouse with traditional west to east airflow, adding a partition wall breaks the airflow. It kind of ruins the cooling pattern of the greenhouse. So this is something where even if you don't want to install the partition wall in the beginning, we would have to know that it's potentially going to have a partition wall to make sure that the airflow is going south to north so that we can accommodate a partition wall in the future.
I mean, at the end, yes, that's the much more economical way of doing it, right? can you put an intermediate wall in there? Yes, you can, but it would require most likely some significant alterations to the airflow and the controller. And you haven't really talked about the controller, Josh. Maybe you want to say a few things about a controller and control, because you talked about the heating and cooling earlier. Maybe
Yeah, I
that's
mean,
it.
every one of these greenhouses, Ceres has a controller that we sell, and whatever greenhouse you're running, you should have a controller that understands the equipment you're using and how it's going to use the equipment appropriately so that it's doing what you want. Things aren't fighting each other. In that greenhouse Marc was just showing, we have below shade exhaust fans, we have above shade exhaust fans, we have lights that are reading light levels in the greenhouse so they can dim up and down as needed. We can use EC controlled exhaust fans, a very small amount for humidity control in some places. We might have a dehumidifier. So, you have all these pieces of equipment, but making sure that they're running when they need to run and not, we often have people who don't understand that you can't run a heater and a GAHT system at the same time. The GAHT system instantly cools the heater. Those are just inherent inefficiencies that we try and avoid, and having an appropriate controller that knows when it can and can't do things is really helpful in both economical and successful operation of a greenhouse.
Nicely said.
Are you guys ready?
I used to do sales.
Oh, yeah. Okay, good.
Are we, so the next question is the most popular question we get. It is the most popular blog visited, and it is top of everyone's mind. And that is related to walipinis. So Marc, will you talk a little bit about walipinis and why we shy away from them?
Oh, I love walipinis. I want to show a few pictures. I think this is the typical earth ones. I think most people, I don't know, are there aware, as far as we are aware of at least. Walipinis were made originally or come up with by missionaries from Utah that were going to the Andes. And there are multiple states there. They're high and dry and cold, and they didn't have food. And so there you're really close to the equator, but because of the high elevation, there's really nothing grows. So there was an easy way to build a very cheap greenhouse. And so you basically dig a big trench and put some wood across, and here you have a walipini. This is a low-tech version, obviously. You can make that higher tech. Even some of those this is not even that old with newer versions. The reason that the walipini was invented where it was in the Andes was that's close to the equator, and the sun is basically above all the time. And it's a great use of a greenhouse in that case. Anywhere in North America, and especially the colder climates where walipinis are often used, you see exactly what you see in this newspaper article from The Guardian, which is a reputable newspaper. You can see where the shade is, because we're in North America, the sun is low. Having a high south wall under the ground is great to keep the temperature low, but this is where most of your sun is coming from all winter long. And by cutting that off, you have maybe a well-regulated greenhouse, but you have no light in it. And that is really not helpful. Other issues that come up with this is whether or not it's the fancier version or less fancy. These walls natural walls especially, have the tendency to get all kind of pests to stick to them and grow in them. And once they're there, they're really hard to get rid of. And so that's another reason where walipinis are really hard to run. They need to have plenty of venting because in the summer they still will get way too hot. And so you have all this heat coming in, but then nowhere to go. There are other issues related to a doorway that has to go down into the ground. So if you're in an area where it rains a lot, the rain is going to come and pool there. So there are many issues that make walipinis in the US, and especially the northern states of the US, energetically a good choice, but growing wise is not a very good choice. There are other materials that are not so expensive that will do a much better job getting enough light in, because light at the end is what grows your plants. And if you don't have enough light, nothing will grow.
Yeah. I mean, this is our age-old question. It's always asked. It's kind of wild how often this comes up. And the picture Marc was showing is such a clear reminder of why that is an appropriate technology around the equator, but very much not so in either higher latitudes, whether north or south, because the shading is a huge issue in the winter. The other thing I've seen a lot of is major drainage issues. You often need to dig, have a drain, and then a sump to get that water out. You got to lift it 8 or 10 feet to get it out of there, which is problematic as well. And part of what we do is we try and insulate our greenhouses so they're mostly above ground. We often dig into hillsides a little bit. We can make adjustments to get some of that insulation, but use insulated walls so that we can gain sunlight and still have good insulation. Not as good as being 8 feet deep in the ground, but it's always a balance between sunlight and insulation.
Can I interrupt really quick just because we are at about 7 minutes left in the webinar, and we had a couple questions come up that I think we should address or get around to. Going back to greenhouse orientation, Jesse asks, are there benefits to east-west versus north-south airflow? What would Ceres prefer for new construction?
Well, I mean, I'll start. So greenhouse-wise, we orient east-west greenhouse before we get into airflow. So our long axis is east-west. A lot of other greenhouses are oriented north-south. We orient east-west specifically to have a long insulated north wall. That means that we can capture extra light in the winter. Any light that misses plants hits our north wall, reflects back on the plants. A north wall in the northern hemisphere is a heat-losing wall in the winter. And so we have a long insulated north wall. East-west airflow versus north-south airflow really depends on the length of the greenhouse and as well as the humidity of the ambient air. But with traditional evaporative cooling, whether that be a wet wall or a fogging system, depending on what's happening outside, the common statement is at 100 feet of east-west distance, you start to lose the ability to cool that air. So if you have a 150-foot greenhouse east to west, the last 50 feet aren't going to see much cooling. The water's been evaporated, it's already rewarmed, and now we've got a hot east side of the greenhouse. For us, with the long greenhouses, we can go north-south now. It's always, we have some set footprints, 23-foot deep north to south, 30-foot deep north to south. So we could have a 500-foot long greenhouse, and if we're always pulling south to north, the air run is only 30 feet. And so we can always go north-south and get cooling. Now, the thing about north to south that we're always talking about is we have to intake air from the south, that means, and usually low on the south wall. So in snowy climates, that can become an issue if there's 3 feet of snow on the ground and our intake louver starts at 1 foot up to 3 feet off the ground. So now it's buried under the snow. We can't move the air so well. So there's all kinds of things that we're thinking about when we're designing these greenhouses to figure out the best way for them to work with the least annoying issues that the grower is going to have to deal with as they operate the greenhouse.
But maybe to add to that, Joe, right? So when we have a greenhouse in a colder climate where we are talking about with this much snow, you generally, we would say, you know, from starting in November-ish to February, March-ish, you don't really have to open the louvers. The GAHT system, if you have one installed, will take care of whatever you need to do, because we do not, in the winter months, want to get rid of the heat that the sun is providing. We want to keep the heat in the greenhouse so that, or under the greenhouse, so that heat is available for when you need it, especially at night. So that issue about the inlet on the south side, just like this greenhouse I just showed in Minneapolis, that is really not an issue, because in the winter, basically those vents will never be open. The GAHT system will take care of everything. There's no need to vent, and we want to keep as much of the energy as we can. It's free.
Great.
Okay, really quick, maybe this is, or do you want to wrap it up, or
No,
one more
if
question?
you guys are just aware that we only have a couple more minutes, we'll definitely have to have a follow-up with more question and answer. But in 2 minutes, could you speak to the efficiency differences between a GAHT system versus the trenched piping system, greenhouse and the snow design? And if that's going to take a little bit longer, we can push it.
I mean, Mark, I don't know how.
Yeah,
I don't know how.
I looked at that quite a bit. So the greenhouse as a snow design is lovely concept, and I want to say the main difference is the amount of airflow. The GAHT system is directly effective, or directly in proportion to the amount of air. If you get double as much air, you get double as efficient, as long as the heat is exchanged, which has other implications in terms of pipe lengths, etc. The greenhouse of the snow design is not having a lot of air. As far as I'm aware, the air movement is significantly lower, and therefore you get good heat exchange, but not a lot of it, which means you have just a little bit of you have less of an efficiency that you're going to get out of that. You know, it's a, you know, greenhouses of snow, or it's definitely a cool greenhouse, and I applaud them, because they're on the right track, right? They're doing the right thing.
Yeah, and they grow citrus.
Yeah.
Traditionally, which only can't freeze, right? That's citrus. Citrus's goal is not freezing. And so the way they're doing it, and again, like what we call the GAHT is known as a climate battery in, like, you know, the permaculture world or wherever it is. All we've done is engineered it more. You know, we've put a lot of time and effort and math and engineering to it to try and maximize its efficiency and performance. So they're similar concepts, different, slightly different way of applying it.
And several PhD and master's theses being done on this already. So there's on the GAHT system, there's several universities that have done that. One in Canada, the University of Guelph, one in North Carolina, in Boone, App State. So there are multiple studies on our design, et cetera, that are there. So this has been studied quite a bit. And there, if somebody wants scientific info, reach out to us. We can provide links for that.
Thank you, everyone. We are at 1 o'clock, so we do need to cut this short here. We only got to a fraction of the questions, so we'll have to have a follow-up. Haley, do you want to?
Yeah, so just on this last slide, this is the email. If you have any questions, or we didn't get around to your questions, please email us at info@ceresgs.com. Make sure to mention the webinar in the subject line so we know where you're coming from. And yeah, we'd like to thank you for joining. We'd also like to mention that for those interested in professional guidance, we offer a range of consulting packages. So if you're interested in those or learning more about those, you can also email info@ceresgs.com. or you can also follow us on social to keep up with what we're doing. So thank you so much, everyone.